Hey everyone, I'm Akhila Chitiprolu. I manage the security and compliance function here at Sierra. I'm joined by Kevin Gao, our head of platform engineering. We'll share today the rise of agents, how they came to be, who are using these agents and how. We'll also share a number of opportunities and challenges that come with the use of agents. We'll share Sierra's own approach to how we handle security, privacy, and reliability of these agents. And Kevin will also walk us through the anatomy of an agent, what guardrails to place, and how to manage a large, scalable conversational AI platform. If you remember the age of the internet, where every business launched a website to basically interact with their customers, in the mobile era, we saw that every company then built mobile apps to interact with customers. In the same way, in the age of AI and LLMs, every company is and going to use agents as the primary interface to interact with their customers. Being in the security industry, we've already seen the shift from when we went on-prem to cloud and started using the cloud security providers. We've learned to use shared responsibility models, and security primitives and guardrails evolved with the cloud infrastructure. In the same way, we expect that in the agentic AI world, there will be responsibilities across customers and the various providers, whether those are large language model providers or the agentic AI providers. A little bit of Sierra, where we see that customer experiences can be greatly improved through human-like experiences, where a typical chatbot that can answer or look up an order for you can now chat with you, send an email, message you on your phone, or even speak to you. And these are all different ways in which agents are already interacting with consumers. And what's more exciting is that these agents are already adopted across a range of industries. For example, if you see a retail industry in a chatbot way, it could only look up an order. But today, an agent in a retail industry can be used to not just look up an order, but to actually place that order, change shipping information, or even troubleshoot any delivery issues. In a healthcare situation, a patient can check up on their latest claim update, can ask questions on explaining what benefits they have or not. It can also help with billing questions that a patient might have. In the same way, in financial services, the agent can now look up account information, help dispute transactions that you may have. And these are the only start of how different industries are looking at solving consumer-facing problems through sophisticated workflows. As we just spoke about agents solving sophisticated workflows, it just means that the responsibilities that these agents have are pretty broad and pretty complex. Clearly, agents can think, reason, and take action, which the traditional software we all grew up with, that was rule-based, couldn't do this. This means there are new forms of risks that arise with the use of agents. Take example of non-determinism. Since we're no longer using a rule-based software, there is no same answer that you can expect from that agent. But this just means we'll have to apply additional guardrails to see where determinism is absolutely required versus not. And these are the flexibility that the agent should provide by default. Same with autonomy. We talk about agents being able to take action autonomously, and they can make tool calls and give output to the end user. This means we have the responsibility to add need-to-know access and appropriate authentication to these agents. And these are just some examples, right? So let's talk about explainability. This is something we would need, especially in the world of security and compliance, to backtrack how the agent came about the decision that it did, how it brought out the output that it did. And this is also especially useful, goes back to auditability and even for forensics. But this is not all. This is just the beginning of how many risks that agents will bring, and those are continuously evolving in today's industry of agentic AI. We talk to hundreds of customers every day. AI security leaders are asking all the right questions. How can I monitor my agent's performance? What if the agent goes off script? How do you handle prompt injections? And also, how do you manage the agent decision logic? And many more. And these are the right questions that we should be asking and building security and responsible AI guardrails around. We talked about agents being able to think, reason, and take action, which at the tip of the iceberg means as long as we have an LLM, a RAG, and are able to make a tool call, an agent can be deployed. With the commoditization of the RAG tools, with MCP, it's more easier than ever to launch that first agent. But that's just the basics of an agent, and that's just the user-facing layer for that agent. As we think deeply about our customer needs, and as we deploy these agents across the various industries, and especially in the regulated industries, questions come up around intent-based routing. How are we doing handoffs? Where is human in the loop? How do I test that my agent is working appropriately? What do voice support look like? If I deploy for chat, does it equal deploying for voice also? What additional work do we need? And this just means we should think more deeply about how the agent might work in real time. And this is exactly what Sierra is doing to enable enterprise-grade agents that are more supported at the platform level, at that enterprise level, and not just calling an LLM and making a tool used to take that action. This is where Kevin is going to deep dive into the autonomy and anatomy of the agent, and also speak about how we think deeply at the platform level on security, responsibility, and reliability of managing AI agents.
Thanks, Akhila. And yeah, as Akhila alluded to, just doing LLM calls, tool calls, and using RAG is just the tip of the iceberg. But we want to make it as easy as possible for our customers to adopt agents securely and run them in production reliably. And so that's why we built Agent OS, our platform. And if we start at the base of the platform, all our agents are based on a constellation of models that we govern to ensure that we're meeting security and compliance requirements. But at the same time, we're still providing the sort of best of breed performance for agents out of the box for customers. And then the next layer up, we have a pretty core piece of our platform and foundation, which is our Agent SDK. So the Agent SDK allows you to declaratively and in an introspectable way define your agents. And this allows you to build sophisticated agentic workflows that can take very complex actions, very long trajectories. So sessions lasting, 20, 30 minutes with a user, and allows you to also, importantly, inject determinism where you need it. So if you need to be able to enforce a critical policy, or you need to handle a sensitive action, you can do that all with, good old-fashioned programming, and give you the assurances that you need that, we're not leaving it up to chance because an LLM thought it would be a good idea. Additionally, the SDK ships with guardrails out of the box. We call some of these supervisor agents. And so we'll go into this in more depth in a little bit. But the SDK is also very extensible. It allows you to define your own custom supervisors, and also allows you to extend and define your own guardrails as well. We do realize, however, though, that not everyone who wants to develop an agent is a technical person or engineer. And so we also provide our Agent Studio, which allows non-technical folks to build just as sophisticated agents in a no-code way using natural language And what's really powerful about this is it's built on top of the SDK as well, and it works harmoniously. So you can have both non-technical stakeholders and technical stakeholders developing collaboratively on the same agent, reaping the benefits of both the guardrails that each other define, as well as the workflows and agentic actions that each person is building. And lastly, it's not just about building the agent, it's also about what happens once that agent is released into production. This is where we think it's super important to provide both monitoring of your agents, not just for how the agent is performing against your KPIs, but also in terms of, are you seeing any regressions in the agent's performance or any regressive behaviors? Are you actually seeing any detections of threats or abuse against the agent from various threat actors? And so we surface all of this in very easy to analyze reports and also insights as well. And importantly, and we'll go over this in more depth, as part of our agent development lifecycle, we make sure to incorporate a very rigorous testing cycle as well. So we make some facilities that enable you to perform what we call simulation tests and create a suite of both simulation and regression tests. And also as well, when you're trying to optimize your agent, we make it as easy as possible to do experimentation, run A/B tests, and make sure that this is all working within a very structured and secure agent development lifecycle. And so taking a step back, wanted to just talk through again what the principles are when we think about deploying agents. So one is security, being responsible as we deploy AI, which is a new technology. And third is reliability. And reliability here is not just reliability in the business continuity sense, but also accuracy, performance, and being able to use sort of best models available while still maintaining uptime as well. On the security front, this is where we're going to do a deep dive. We take a very defense in-depth approach to security, starting with the foundations of our secure agent development lifecycle. And then I'll also go through and walk through in a more general way how we think about agents, walking through all the sort of threat vectors that we see with agents and because of this new software paradigm, and then also talk through mitigations as well. Starting again with that foundation of the secure agent development lifecycle. First is actually defining and building the agent, maybe for the first time. And so what we want our agent developers to care about is defining the goals and, importantly, the guardrails for their agents. And these are the things that help determine agent behavior as well as safety mechanisms to make sure the agent's not veering off course. And then once you have the initial version of the agent built, before you even release it to production, again, we want our users to build out that suite of simulations. You can use the platform to also help you generate those scenarios and simulations and regression tests. And this is to ensure that before any release, your agents are robust, not regressing, and performing well. And we also recommend here including things like red teaming exercises, so including malicious prompts, if you will, to make sure that those agents are staying robust to those as well. We incorporate into the product a very structured change management lifecycle, which mirrors what you might think about in a software development lifecycle. And so you can cut new releases that are hermetically sealed, point in time, release them, roll them out slowly, roll back. And we want to make sure that our customers have all the control to be able to do this if they do see any issues or want to have full control over their change management. And lastly, I'll just briefly touch on your agent you should be constantly evaluating your agent's performance. And so this is done using a mix of analysis, reporting, and also just proactive insights that we surface to our customers. And lastly, you use this analysis in order to restart the loop, optimize your agent performance, and improve your agent over time. And so now I just want to go through the anatomy of how we think about an agent in the modern day. Agents are actually not a new concept. There's a lot of literature and academia on them. The academic definition is an entity that's capable of acting on an environment and doing that autonomously. And so if you think about that in the modern day, and I think in the industry, what people have come to think about agents, really, I think there are some core components here. So the environment that agents are interacting with are external business systems, as well as things like your data stores, knowledge bases, etc. There's also, they're usually acting on behalf of an external user. And so there's some semblance of input and output involved as well. And then the sort of like core piece of what we think about the agent is oftentimes powered by an LLM or large language model. And oftentimes these LLMs provide capabilities such as planning and also reasoning. And the last sort of component here I'll just briefly touch on is memory. One of the powerful features of sort of the best modern day agents is this idea of memory. You can use that to personalize experiences and also just keep track of things that worked, didn't work to improve performance over time. And of course, with all this and this new paradigm of agents brings a lot of new threats. And so essentially every component of this anatomy or architecture is a new threat vector, essentially. And so we'll start with maybe the most obvious one, which is inputs and outputs. And from the perspective of users being potentially untrusted or oftentimes untrusted, it opens you up to an attack known as prompt injection, which Akhila had mentioned. Prompt injection is where a malicious input is used to cause unintended behavior for the agent. That may be either taking unintended action, trying to leak information or exfiltrate data. It could also be trying to overwrite the system prompt in order to essentially take over the agent or even affect the output in a way that causes reputational harm. And so the first thing we would suggest here is implementing what would be called an input guard. Essentially what this is a classifier or set of classifiers that runs over the input before passing it along to the core piece of the agent in order to classify to see, is this potentially abusive or a threat or malicious? And then if so, determine what action you want to be able to take, whether it's ending the session, blocking the user, escalating to a human. These are all valid examples of what you could do upon detecting that. And an often forgotten piece of this as well is being able to do output filtering. Because of the non-deterministic nature of LLMs and this whole system as a whole, agents have the ability, even if an input passes your input guards, it could have the ability to produce some output that may, cause reputational harm, or just generally not be good or leak data, etc. And so it's still important as a next step to also include that output filter, so you have those same protections, even if something happened in between the input and outputting the data. The next piece I want to talk about is protecting your trusted systems. And so here I'll highlight two. Your business systems are definitely within the trust boundary that you want to protect. Your knowledge base as well should also be within a trust boundary. And I'll start with the business systems here, but the principles apply across the board. So you want to leverage, your existing best practices around identity and access management. So make sure that your agents have a clear identity and that they're not overly scoped in access, and you're using secure communication, authentication that follows best practices and standard protocols, as well as authorization that minimizes scope and access. I also want to talk through a slightly more advanced technique here. One of the nuances with agents is they often have service account level access to some of these systems. And one of the more advanced techniques you can implement is to actually downscope the level of access they have based on the context, whether that's the user, the session, the intent of the session, to limit the blast radius of what could happen within that agent and protecting it with traditional access controls. In addition, having more guardrails, we implement these in our SDK and our Agent Studio as policies and standard operating procedures that protect the agent from taking the wrong action or doing something that goes against your policies is very important. And as I alluded to before, for very critical processes or systems or policies, you may actually just want pure deterministic logic to handle these. Take, for example, refunding a user money from an order, or, for example, making account changes. Those are very sensitive operations. You don't want to leave that up to an LLM to determine what tool to call when, what data to pass where. And so being able to fall back and inject that determinism where you need it is super important. And the next area I want to talk about is knowledge itself. So LLMs have essentially been trained on the entire archive of the internet, especially for companies that have a relatively large presence. A lot of the knowledge about a company may be in that latent training data from the pre-training period of the LLM. And so it's really critical that you are leveraging trusted knowledge sources and grounding your data in that knowledge. and ensuring that your retrieval augmented generation pipeline, that RAG pipeline, is being leveraged well, and that you're not hallucinating answers. And there are various techniques to do that. And lastly, I think even if you are using a trusted knowledge base, which we highly recommend, you still are prone to some threat vectors, such as you can imagine a insider threat where a disgruntled employee who has access to the knowledge base because of their role injects some malicious knowledge that attempts to overwrite a system prompt, attempt to wreak havoc, or just exfiltrate data. Any of those examples is possible, and I definitely recommend putting in essentially sanitization and validation when you are reading this knowledge. And you can also implement out-of-band processes to essentially audit your knowledge bases. I would also recommend here having change management and versioning for those knowledge bases. And we sort of incorporate all of these into our agent development lifecycle and that release process for agents. The last piece I'll talk about as far as something to consider here, and this is not an exhaustive list, is for highly sensitive actions, you may want to consider a user experience where if the agent wants to take a very sensitive action, say, for example, drop a database, you may want to actually include a human in the loop there to review and approve the action that the agent wants to take before actually allowing the agent to execute it. And we talked a lot about the agent anatomy itself, threat vectors, how to mitigate them. There's also so much more that are outside of the agent anatomy and the agent runtime that you should consider. We talked about evaluations. There are companies and firms that do red teaming now, and also internally, you should be doing your own red teaming. We talked about regression tests being super critical to make sure that as you're developing your agent over time, it's not falling behind in performance or safety. Talks quite a bit about change management. So incorporating that and the best practices you've learned from, say, software development is extremely key. And an interesting principle as well is to not forget about your traditional InfoSec practices and controls. A lot of the same threats actually apply, or the way that threats are explored apply. For example, when people are trying to do prompt injection, there's now automated tools to essentially try all the new techniques. And so if you actually invest in traditional techniques such as rate limiting, that can be extremely helpful for making your agents more resilient and secure. Lastly here, make sure you're monitoring your agents. And once they're in production, to be responsible in your deployment of AI, you want to make sure that your agents are traceable. There's explainability in why the agents did what they did. And you also have audit trails for all the actions the agent took. And to talk about what I mean by explainability, here, for example, is just a simple user inquiry talking about wanting to cancel their subscription. But when our demo agent here receives this, it actually goes through, does a lot. It receives the context of who the user is, grabs data about the user. It looks at, what offers they're eligible for. It will update some systems of record. It'll try to detect abuse that's happening, and then take in some input and essentially decide what to do next. Even though this is just a very simple one-line query, if we see the response, we want to be able to know why that response is generated. And the last piece here, hopefully, if you're adopting agents, you're adopting them because it's going to make an impact on your business. And because of that, it's not just about security, it's also about business continuity and making sure that your agents are actually up and available, because presumably you put them into pretty critical paths. And so one of the things that we found, LLMs are a very new piece of infrastructure. And because of that, we've found historically in recent time that model providers can go down and can have less uptime than would be desirable for a mission critical application. And so we've invested a lot into essentially building an adaptive router layer, which can in real time be monitoring the health and latency of all our providers. And we will adaptively shift traffic over to failover in real time to essentially have zero downtime. And how we achieve that zero downtime as well is through a mix of other strategies such as retries, or we reduce latency for tail latency by hedging requests. And so these are all systems techniques that are very applicable, and especially because LLMs are such a new piece of infrastructure.
Thank you, Kevin, for that detailed agent anatomy and architecture overview. I'm sure our audience appreciate the details. And to recap, really, we learned that agents are here to stay. Agents are multi-modal, omni-channel. They can speak many languages. They can interact with the end users through chat, email, messaging, and voice. And companies across the various industries are quickly adapting these agents. And like Kevin mentioned, the business purpose of why that agent is enabling your business is important. And that also directly translates to the kind of AI agentic vendor that you may choose to build with, or even if you're building the AI agent internally, we've learned that it takes quite a bit of platform level thinking and not just what's on the tip of the iceberg. We should also dig into, as security experts, into the architecture of the agent, the anatomy, what kind of models are being used, and how those decision-making and deployment paths look like, so that we're not just looking at the security at the top layer, but actually looking deeper for those defense and depth controls, and where required, have that flexibility for the agent to either be deterministic or non-deterministic, to determine the level of autonomy that agent needs. And going back to basics on security, we should evolve our first principles on how we think of secure by design, or privacy principles, or shared responsibilities, but in the world of agentic AI capabilities. Because today, to build enterprise-grade agents, we cannot just quickly launch an agent because it's easy to do so, but we should be doing that to scale the agents in a responsible and secure manner. Thank you.